Hello, welcome to Extreme Diag. Today, I'm working on a 2011 Ford Escape. The owner reports that the vehicle keeps stalling while driving. After restarting, it drives normally for a while but then stalls again. It must be really frustrating when the engine stalls while driving. If this symptom occurs in your car, you should get it checked as soon as possible. It's one of the most dangerous symptoms. Today, I'll show you how we diagnose and solve this problem. First, I'll run a scan. When diagnosing engine warning lights, I usually start with a scan, display the relevant PCM real-time data on the scan tool screen, and then go for a test drive. The scan results are in. It's code P2111. This code indicates a problem with the throttle body. I'll look into what exactly this code means later. The throttle body is a device that regulates the amount of air entering the engine based on accelerator pedal input. If this part malfunctions, it can severely affect the vehicle's operation. Just to be safe, I won't take the test drive too far. What you're seeing now is the PCM's real-time data. I've filtered out only the data relevant to the diagnosis for clarity. I've narrowed it down to data related to the accelerator pedal and throttle body. Wait a minute, the vehicle is acting strange. It's not moving. I wasn't sure if the symptom would appear on the first drive, but fortunately, I confirmed it before even hitting the road. You can see this wrench-shaped warning light here. This light comes on when the system detects an error in critical components like the throttle body or transmission that could severely impact driving. Right now, I'm pressing the accelerator pedal all the way down to the floor, but the car won't go any faster than 10 km per hour. This is called default mode or limp mode. When there's an issue with the acceleration control system, the computer significantly limits engine output to prevent unexpected situations like sudden acceleration. In this mode, the car barely has enough power to pull over to the side of the road. It seems like the customer is asking us to fix this symptom, so let's move on to the next step. We've brought the car into the shop. This is the throttle body. Before diving deep into diagnosis, I'll start with a basic inspection. First, I'll disconnect the throttle body connector to check for visible issues like corrosion. It's too tight to get a good grip with my fingers. I'll use a tool to disconnect it. Once disconnected, I'll inspect the front and the throttle body side carefully. The throttle body side isn't very visible, so I'll use a magnifying glass for a closer look. Nothing seems unusual. I'll remove this hose in front of the throttle body to check for mechanical defects. With the hose removed, you can see the throttle body mechanism. I moved the throttle body valve with my finger, and it moves smoothly. This concludes the basic inspection. First, I'll check the TSB. I'll search for the error code P2111. Nothing comes up. I'll try searching for throttle body instead. 2 results appear. Having worked at Ford before, I can tell from the document number format that both of these are recall notices. I'll check the bottom one first. Since it's an older car, I'll check the validity period first. The validity period has long expired. The service action here says to reprogram the PCM. To do this, you need a dealer-exclusive scan tool connected to Ford's server, which we don't have in our shop. I'll check the next document now. Checking the validity period again, it's also expired. The service action states that if a throttle body related error code appears, replace the throttle body. Now, I need to discuss whether to proceed with diagnosis, send it to the dealer for a PCM update, or just replace the throttle body. After discussing, we decided to proceed with diagnosis. It's been a while since I worked on a Ford, so today I'll follow the dealership's textbook approach. First, let's look at the conditions that trigger the code. I'll go into Diagnostic Trouble Code and search for P2111. Here, it says, this powertrain control module fault status indicates the throttle plate is at a greater angle than commanded. Earlier, I manually moved the throttle plate, and this code appears when the angle exceeds the PCM's commanded position. Here's a list of possible causes. In short, the issue could be the throttle body, wiring, or the PCM itself. Next, I'll proceed to the pinpoint test, to volts. DV1 asks if any of the listed error codes are present. The answer is yes, and for P2111, proceed to DV5. DV5 instructs to check for obstructions in the throttle body. Remove the hose and inspect the throttle body mechanism. We did this during the basic inspection, right? The answer is yes, so proceed to DV6. DV6 is lengthy, but in summary, it says to monitor the throttle position's real-time data with the scan tool and compare it to specifications. Typically, the throttle body has 2 position sensors, abbreviated as TP1 and TP2. I'll take a photo of this chart and head to the car. We need to check the TP1 and TP2 data values with the accelerator pedal pressed and released. Unfortunately, it didn't show up well on camera. With the pedal released, TP1 showed 4.0 volts and TP2 showed 1.2 volts. With the pedal pressed, TP1 showed 0.9 volts and TP2 showed 4.4 volts. Comparing these values to the chart, everything seems normal. The question is whether the data values are within the normal range. The answer is yes, so proceed to DV7. DV7 says to check the sensor power supply at the throttle body. Disconnect the throttle body connector, turn on ACC mode, and check the voltage between the ETC-REF and ETC-RTN pins. Looking at the throttle body connector pinout, ETC-REF is pin 5, and ETC-RTN is pin 4. I'll check pin 5 and pin 4 on the throttle body connector. This is an actual photo of the connector and the pins are numbered from right to left as 1 through 6. Back in the car, I'll turn on ACC mode and check the voltage between pins 4 and 5. It reads 5.01 volts. The question is whether the voltage is between 4.5 and 5.5 volts. The answer is yes, so proceed to DV8. DV8 says to reconnect the throttle body connector. Rescan to check if codes P2101 or P2107 appear. I'll skip this step. If those codes were present, they would have appeared on the initial scan. Since only P2111 appeared after confirming the symptom, rescanning won't make a difference. The answer is no, so proceed to DV14. DV14 says to check the throttle body's resistance values. Component side means testing the part itself, not the wiring. Check the resistance between TP1 and ETC-REF, and between TP2 and ETC-RTN. Looking back at the pinout, between TP1 which is pin 3, and ETC-REF which is pin 5, and between TP2 which is pin 6, and ETC-RTN which is pin 4. The pinout I just showed is for the vehicle wiring side of the throttle body connector. For the component side, the orientation is reversed. Leftmost is pin 1, rightmost is pin 6. Between pins 3 and 5, it reads 10.00. The multimeter automatically switches to the K setting for high resistance. Multiply by 1000, so the resistance is 10,000 ohms. Between pins 4 and 6, it reads 9.88. Multiply by 1000 for 9,880 ohms. The question is whether the resistance is between 9,000 and 11,000 ohms. The answer is yes, so proceed to DV15. DV15 says to check the throttle body's diodes. On the component side, check the diodes between ETC-RTN and TP1, and between ETC-RTN and TP2. Referring to the pinout again, between ETC-RTN, which is pin 4, and TP1, which is pin 3, and between ETC-RTN, which is pin 4, and TP2, which is pin 6. Since we're testing the component again, we need to reverse the pin orientation. Set the multimeter to diode mode. Between pins 3 and 4, the reading was 0.407 volts. Between pins 4 and 6, it reads 0.413 volts. The question is whether the voltage is between 0.2 and 0.9 volts. The answer is yes, so proceed to DV16. DV16. It says to check if there's a short to power on the TP1 and TP2 circuits. A short means a situation where parts of an electrical circuit that shouldn't be connected end up touching, causing current to flow abnormally. We'll disconnect the PCM connector, turn the key to ACC mode, and check the voltage at TP1 and TP2. This vehicle has 3 PCM connectors. If you look at the throttle body wiring diagram, this is the PCM, and this is the throttle body. See the C175E here? That's the connector number we need to disconnect. If you look at the diagram, the C175E connector is the one in the middle. We'll disconnect this connector, turn the key to ACC mode, and check if we get voltage at TP1, which is pin 3, and TP2, which is pin 6. This is the PCM, the computer that controls the engine. And we'll disconnect the middle one of the 3 connectors. Connect the black probe of the multimeter to the battery ground. The The key is already in ACC mode. Now, checking the voltage at pin 3 and pin 6. We get no reading at all. The question was whether voltage is present. The answer is no, and it's directing us to DV17. DV17. Now it says to check whether the TP1 and TP2 circuits are open. We'll check the continuity of the TP1 and TP2 circuits between the throttle body connector and the PCM connector. First, we need to find the pin locations of TP1 and TP2 at the PCM connector. At the C175E connector, TP1 is pin 41, and TP2 is pin 58. Let's take a look at the C175E connector pin layout. Here is pin 41, and here is pin 58. Now we'll check the continuity between these pins and the throttle body connector pins. For simple continuity checks, we measure resistance. Lower resistance values indicate better connections. The TP1 circuit shows 0.6 ohms. The TP2 circuit shows 0.9 ohms. The question is whether the resistance is below 5 ohms. The answer is yes, so proceed to DV18. DV18 says to check for shorts to ground in the TP1 and TP2 circuits. I'll perform this test at the throttle body connector. Measure resistance between TP1 and TP2 pins and battery ground. TP1 reads OL. And TP2 also reads OL. OL means the resistance exceeds the measurable range, indicating no connection. The question is whether the resistance is above 10,000 ohms. The answer is yes, so proceed to DV19. DV19 says to check for shorts between the wires. Check for shorts between TP1, TP2, ETCREF, and ETCRTN circuits. All readings are OL. The question is whether the resistance is above 10,000 ohms. The answer is yes, so proceed to DV25. DV25 says to check for intermittent issues in the throttle body wiring. By manually shaking the throttle body wiring while monitoring TP1 and TP2 data values on the scan tool. Reconnect the PCM and throttle body connectors. Turn on ACC mode and monitor the PCM real-time data on the scan tool. TP1 shows 4.09 volts, and TP2 shows 1.21 volts. No matter how much I shake the wiring, the voltage on the scan tool does not change. The question is whether the voltage is between 0.49 and 4.65 volts. The answer is yes, and the conclusion is to replace the throttle body. In summary, since no issues were found in the wiring, replace the throttle body. If the symptom persists, replace the PCM. This concludes the diagnosis.
"2,000 years later."
The customer approved the repair. The part has arrived, so I'll proceed with replacing the throttle body. I can't use my bay right now due to another car occupying my bay, so I'll do the replacement in a co-worker's bay. Throttle body replacement is relatively straightforward, so I'll get it done quickly. First, disconnect the hose connecting the air filter and throttle body. Then, disconnect the throttle body connector. Next, remove the 4 bolts securing the throttle body. Remove the throttle body. Replace the gasket. Reconnect the connector. Position the new part correctly, and tighten the bolts. Reattach the hose and tighten the clamp. Give it a final check, and the part replacement is complete. After replacing the throttle body, reset the PCM using the scan tool. Also, double-check error codes. This completes the repair. The test drive was completed without any issues. With that, I'll wrap up this job.
What happened?
I won.